Hi, this is Matt Baker. Last year, I did a series on my evolutionary tree of life chart. In the episode on plants, I also covered fungi, but not very in-depth, which led this person to comment,
"Fungi only getting 5 minutes is a crime against humanity."
Well, today I'm going to restore order in the universe by doing a full video on just mushrooms and other fungi, using this brand new classification of plants and fungi chart. What you see here is the first in a series of charts that I'll be creating in order to show you the tree of life in even greater detail. I decided to start with plants and fungi because, well, I've been on a bit of a gardening kick lately. Gardening, of course, is usually more about plants, but as anyone who spends a lot of time with plants will tell you, wherever there are plants, there will also usually be fungi. Therefore, I decided to keep these two kingdoms together on a single page. Today, we'll be looking exclusively at the fungi section, but in future videos, I'll show you the plant sections as well. As usual, if you want to get a copy of the chart as a poster, just head over to usefulcharts.com or simply click the link in the description or pinned comment. Okay, so the first thing you need to know about fungi is that they are not plants. We tend to think of them as being like plants because they are immobile. But when it comes down to it, fungi are actually more closely related to animals than they are to plants. Let's start here at the bottom with eukaryotes, which is the term used to describe all living things other than bacteria and archaea. Well, eukaryotes can be divided into two main categories, biconta and amorphia, which used to be known as uniconta. Bi means two and uni means one. So what does conta mean? Well, it refers to the little tails that early eukaryote cells had called flagella. Some cells had two flagella, hence biconta, whereas others had only one, hence uniconta. The biconta category includes algae and plants, whereas the uniconta or amorphia category includes fungi and animals. Now, before we look at fungi, let me point out two types of mold that, unlike most molds, are not actually fungi. These are the water molds belonging to the Oomycetes class and the slime molds belonging to the Myxogastria class. A good example of a water mold is the potato blight that caused the Great Famine in Ireland in the mid-1800s. And a good example of a slime mold is the bright yellow and very spongy mold that sometimes appears on tree bark. Okay, let's now dive into real fungi. The first fungi I want to talk about is often found on moldy bread. Not the green kind, which we'll get to later, but the fuzzy gray kind that often forms if you leave a sandwich in a container and then forget about it. If you look at this kind under a microscope, you'll see that it's actually a bunch of tiny white threads with black tops. This explains why it and other members of the Mucoromycotina phylum are known as pin molds. Now, since I've only shown one species in this entire phylum, this branch serves as a good example of the various taxonomic levels that are used to classify living things. If we start at the level of a kingdom, such as fungi, what comes next is a phylum, followed by a class, an order, a family, a genus, and then finally, a species. Take note that genera and species are always shown in italics, and that a full species name always includes the genus as well. Now, before we move on, let's take another close-up look at black bread mold. The tiny threads you see are called hyphae, and taken together, the entire network is called a mycelium. Most fungi have a mycelium, and it is actually the main part of each fungal organism. Take, for example, mushrooms. Most people assume that the visible mushroom is the fungus, but it's not. Underneath a patch of mushrooms in the ground will be a mycelium, and it is the mycelium that is the fungus. So keep that in mind as we move on. The rest of the fungi we're going to look at are all considered to be higher fungi, and these can be divided into two main categories. those belonging to the Basidiomycota phylum, and those belonging to the Ascomycota phylum. You'll notice that a lot of these names include myco or myci in them. That's because that's the Greek word for fungus, which also explains why the study of fungi is called mycology. The word Basidiomycota roughly translates as club fungi, whereas the word Ascomycota roughly translates as sac fungi. Basically, Basidiomycetes are often shaped like clubs, whereas Ascomycetes are often shaped like bowls. Let's look at Basidiomycota first. Before we get to the main mushroom class, which tends to be everyone's favorite, let me point out a few other types of Basidiomycetes. First, there's the Ascomycetes class, which is made up of smut fungi. These are crop-killing parasites that mostly infect plants in the grass family, such as wheat, rice, and corn. Then there's the Tremellomycetes class, which is where we find jelly fungi. The kind shown in the image is called witch's butter, and it is usually found on bark or rotting wood. Finally, there's the Pucciniomycetes class, which includes the various types of rust fungi, yet another agricultural parasite, this time found mostly on leaves. It's called rust fungi because, well, it tends to look like rust. Okay, we've now come to the Agaricomycetes class, which is where we find most of the species we call mushrooms. But first of all, what exactly is a mushroom? As I mentioned earlier, the main part of a fungi is the mycelium, which is often located underground. This might lead you to think that mycelia are the equivalent of plant roots, but this would be incorrect. If you want a rough analogy from the flowering plant world, it would be better to say that mycelia are the equivalent of every part of a plant except for its fruit. And mushrooms, well, they are the fruit. Now, when we think of a mushroom, we usually tend to think of the kind that has a stem, cap, and gills. Well, this is actually just one type of mushroom, the technical term for which is an agaric, hence the name Agaricomycetes. But there are lots of other types as well, as we'll see when we get to the Ascomycota phylum. Even that yellow jelly we just saw below is a mushroom. So as we go through the Agaricomycetes class, remember that what we are looking at are not only mushrooms, but more specifically agarics, or at least fruit bodies that are very close to being agarics. For example, take polypores from the Polyporales order, commonly known as shelf fungi. They have caps and gills, but no stems, because they grow off the sides of trees instead. Or the boletes from the Boletales order, which have stems and caps, but no gills. Some boletes are edible, but others are poisonous. Which reminds me, do not use this chart as a guide to identifying which species of mushrooms can be eaten. There are thousands of different types of agarics, and unfortunately, many poisonous ones look very similar to many edible ones. So, unless you're an expert, never eat a wild mushroom. Okay, next up is the Geostrales order, which literally means earth stars. I think it's pretty obvious why they're called that. The same goes for these very phallic-looking mushrooms, which are placed in the Phallales order, because they look like, well, I think you know. They're also called stinkhorns because they give off a stinky smell which attracts flies, who then disperse its spores. Then there's the Cantharellales order, which has two genera I'd like to point out. This one, which is made up of mushrooms called tooth fungi because they have a bunch of tiny teeth instead of gills. And this one, which contains the chanterelles, which are orangey-yellowy mushrooms used in French cuisine. Next up is the Russulales order, which again has two genera I'd like to point out. Lactarius, or milk caps, named because they excrete a milk-like substance from their gills, and Russula, which includes the brittle gills, famous for their bright red caps. These should not be confused with the fly agarics, which we'll come to shortly. Okay, we've now come to the Agaricales order, which is the largest order within the Agaricomycetes class. Most of the mushrooms in this order are true agarics, meaning that they all have stems, caps, and gills, although there are a few exceptions, as we'll see. The two most important families in this order are the Agaricaceae family and the Amanitaceae family. Let's start by looking at 7 species from Amanitaceae, all of which belong to the genus Amanita. The most famous of these, if not the most famous mushroom of all, is Amanita muscaria, also known as the fly agaric. It has this name because in medieval times, the cap was cut up and mixed with milk, and then the mixture was used to ward off flies. However, most people nowadays know it because it's the most commonly used mushroom in pop culture. For example, it's the mushroom from the Super Mario games, the mushroom that Smurfs live in, the mushrooms that dance in the Disney movie Fantasia, and the mushrooms associated with fairies and gnomes on vintage postcards. Now, like I said earlier, fly agarics look a lot like brittlegills. The main difference is that the fly agaric has white spots on its cap. Why is this? Well, one of the unique things about Amanita mushrooms is that when they are first emerging from the ground, they have a special veil that protects their cap. However, as they start to grow, that veil bursts and the pieces end up remaining on the cap as little white spots. Like many other agarics, Amanita mushrooms also have a special veil that protects their gills early on. This too eventually ruptures and becomes the ring seen around their stems. Now, the final thing you need to know about the fly agaric is that it is somewhat poisonous, although not as deadly as some others. The most poisonous mushroom in the world, and the one that is responsible for most mushroom-related deaths, is Amanita phalloides, aka the death cap. Its toxicity level is so high that if you take just one bite, you'll probably be dead within a week. Almost as dangerous is Amanita bisporogyra. It and several other related species are known as destroying angels. However, not all Amanita mushrooms are deadly. Take, for instance, Amanita caesarea, aka Caesar's mushroom. This one was supposedly a favorite of the Roman emperors, but once again, mushroom identification can be difficult, so don't ever try to eat one found in the wild. As you might have guessed, Caesar's mushrooms grow mainly in Italy, but in the US there is a similar looking one called Amanita jacksoni. Okay, let's now move over to the Agaricaceae family. The main genus in this family is called Agaricus, and this is where we find the most commonly eaten mushroom in the world, Agaricus bisporus, which is known by many names, including button mushrooms and portobellos. Closely related to this famous mushroom are almond mushrooms, which taste a bit like almonds, and several white varieties that can often be found in fields, such as horse mushrooms, meadow mushrooms, and yellow stainers, so named because they stain yellow when cut or bruised. Unlike most species in this genus, yellow stainers are somewhat poisonous. Some other genera in the Agaricaceae family are the shaggy inkcap, also known as the lawyer's wig, and the parasol mushroom, which looks like a little umbrella. Here you can see that ring really well, the one that started out as a veil protecting the gills. Finally, the Agaricaceae is where you'll find puffballs. If you've ever stepped on a mushroom and then it exploded, causing a little white cloud, that was a puffball. They come in a regular size as well as a giant size in a separate genera. Closely related to the Agaricaceae family is the Bulbitiaceae family, named for their bulbous caps. A good example are mower's mushrooms, which are those tiny brown agarics that are made more noticeable after you cut the grass. Then there's a Hymenogasteraceae family, which is where we find Psilocybe cubensis, aka magic mushrooms or shrooms. These are the ones that people take in order to hallucinate and have psychedelic experiences. These experiences are caused by a compound found in these mushrooms called psilocybin, hence the genus name. Other families in the Agaricales order include Pleurotaceae, containing oyster mushrooms, Omphalotaceae, containing shiitake mushrooms, and Physalicraceae, containing enoki mushrooms. After button mushrooms, these are probably the next 3 most popular in terms of edible agarics. But then there's also Hygropheraceae, containing the wax caps, which are not edible. Schizophyllaceae, containing the split gills, which look a lot like shelf fungi but are much smaller. And Marasmiaceae, containing one of the most well-known fairy ring species. Fairy rings occur when a bunch of mushrooms appear together in a large circle. These serve as a good reminder that mushrooms are not individual organisms, but rather just the fruiting bodies of a mycelium, which is the real body of the fungus. In other words, when you see a fairy ring, what you're actually seeing is a single fungal organism. Imagine it as kind of a tree existing underground, with only its fruit popping up through the surface. The final Agaricales family I want to point out is Clavariaceae, containing Clavaria, aka coral fungi. As you can see, coral fungi are not agarics. They look more like some sort of sea creature. For this reason, they were originally placed somewhere else on the family tree of fungi. But now that we can do DNA sequencing, we know that they're actually quite similar to other members of the Agaricales order, which is why they are now placed here. Okay, so that takes care of the Basidiomycota phylum. It's now time to look at the other major type of higher fungi, the Ascomycota phylum, or sac fungi. This is where we find most yeasts, molds, lichens, mildews, but also several interesting types of non-agaric mushrooms. Let's start with the true yeasts. True yeasts differ from other types of fungi in that they tend to be unicellular and they reproduce by cloning. All true yeasts belong to the Saccharomycetes class and its only order, Saccharomycetales. Within this order, the largest family is Saccharomycetaceae. Since we just saw saccaro being repeated 3 times, you might be wondering what saccaro means. Well, it means sugar. So yeasts are basically sugar fungi. The reason they are called this is because yeasts are known for making sugars ferment. Fermentation is the process by which one substance breaks down another one. Let's take this famous yeast as an example. Saccharomyces cerevisiae, aka baker's yeast or brewer's yeast. When baking bread, the yeast reacts with the sugar, creating little pockets of air, hence causing the bread to rise. The other really important yeast to know about is Candida, which can cause infections in humans. The rest of the Ascomycetes we're going to look at all belong to the subphylum Pezizomycetina. From here, it is the Lichens class where we'll find the majority of lichens. Lichens are interesting life forms because they are actually a symbiosis between 2 different types of life, a fungi combined with either an algae or a bacteria. However, they are always classified under the fungus kingdom, based on whatever the fungal component is. There are 3 main types of lichen, and therefore I've given you one example of each. Caloplaca is an example of a crustus, or crust-like lichen. It belongs to the Taliscistaceae family, which in turn belongs to the Taliscistales order. The other 2 both belong to the Parmeliaceae family, in the Lichens order. Parmelia is a type of folius, or leaf-like lichen. Also known as shield lichen, it forms on old trees, but is gray and more flaky looking. Finally, there's Usnea, also known as old man's beard. It's an example of a fruticus, or coral-like lichen, and it can often be found hanging off tree branches. In the Eurotiomycetes class, in the Eurotiales order, is the Aspergillacea family. This is where we find all of the blue and green molds, such as Penicillium, which is the green mold found on bread. In 1928, this mold was mistakenly combined with certain bacteria, and the result was that the bacteria stopped growing. This led to the creation of the very first antibiotic, a special type of medicine used to treat bacterial infections. However, Penicillium is also used to make other things, such as cheese. Examples include blue cheese, where the blue mold is visible, but also brie, where it is not. Another mold in this family is Aspergillus oryzae, which is used in Japanese cuisine to create sake, miso, and soy sauce. If you've ever wondered what the difference between mold and mildew was, It mainly boils down to color and size. Whereas mold tends to be dark and puffy, think green or black fuzz, mildew tends to be white and powdery, although it can also be light gray or beige. In the Liotiomycetes class, Agaricales order, and Agaricomycetes family, we find the genus Agaricales, better known as powdery mildew. This is yet another type of fungus that commonly infects the leaves of plants. Now, the rest of the Ascomycetes we're going to take a look at are all much more visible. In other words, they are mushrooms, even though they're not the typical agaric kind. Let's start with the Pezizomycetes class, Pezizales order. The main family here is Pezizomycetes, which includes cup fungi. But there's also some more interesting families, such as Tuberaceae, which contains truffles. The main truffle genus is called tuber because true truffles are found underground, like potatoes. Many truffle species are edible, and because they are somewhat rare, they can be quite expensive. Also edible yet expensive are morels, which belong to the Morcellaceae family. They look more like typical mushrooms, but have tall caps with a honeycomb appearance. Also edible is the orange peel fungus in the Pyronomataceae family, but they're supposedly not very tasty. On the more freaky side of things are geoglossums, which literally means earth tongues. They are black and definitely look like tongues sticking out of the earth. They are placed in their very own family, order, and class. Also kind of freaky is the genus Xylaria in the Xylariaceae family in the Xylariales order. It includes this species called dead man's fingers. I think you can see why. And this one called dead mole's fingers. A little less scary is Xylaria hypoxylon, aka candlestick fungi. It kind of looks like a bunch of antlers growing out of the ground. Now, the Xylariales order belongs to the Sorderiomycetes class, which also contains the Hypocreales order. It includes the final three types of fungi that I'd like to point out. First, there's the rather large and orange lobster mushroom in Hypocreaceae. These are edible and commonly eaten. Then there's the rather small and orange caterpillar mushrooms in Cordycipitaceae, which are also edible but not commonly eaten. Finally, I want to point out ergot in Clavicipitaceae. It's another fungus that causes disease in grains, but it's also notable in that it contains lysergic acid, which is used to make LSD. Okay, so that was a look at how fungi are classified. Once again, if you want to buy a copy of the chart as a poster, just head over to usefulcharts.com or click the link in the description or pinned comment. Thanks for watching.